Right. So yeah, hi, I'm Ed. I work at TransitionZero, the not-for-profit TransitionZero, where I lead the team of model engineers. The model engineers, we sort of sit between sort of the energy modelers and the tech team at TransitionZero. And what we're presenting today is the main product that we've been working on, Scenario Builder, and then we'll take a little bit of a peek under the hood to see how things are working in the back end and how we've used PyPSA to actually enable this product. So before we get into that, a little bit about, TransitionZero, what we're about. So TransitionZero builds software to reduce the time to build clean energy at scale. That is our core mission. And our work sits across opening modeling foundations, model-ready data, market insights, and planning workflows. And we help governments, planners, financiers, and other stakeholders across the energy value chain move from data and assumptions to decision-ready evidence. So that's the overall sort of mission of the company. But what we're going to look at today in a bit more detail is our main product, Scenario Builder. Scenario Builder is a managed software environment for energy system modeling and scenario analysis, and it helps users define scenarios, run PyPSA-based models in a managed cloud environment, and compare results for a user-facing workflow, a nice sort of UI on the front end. The goal of this is to make rigorous modeling more easy to run, review, share, and interpret without requiring everyone in that sort of chain to work directly in Python. So yeah, let's get to it. So I like to live dangerously, and what that means is we're going to do a live demo and see how that goes, but it'll be fine. So I've just clicked on this link here, builder.transitionzero.org, and that takes you to, Scenario Builder. So Scenario Builder is just a website that anyone can log into at the moment. So I'll just log in here. If you were to follow that link yourself, anyone can at any point. This is just where it would prompt you to sign up. So I'll just log in and show you the sort of things we can do here. So it's taking me to my home screen now. A little refresh. Oh, fantastic. Okay. Right, so I've got a few projects I've created before, but for purposes of this demo, let's create a new project. Um, let's go call this Pipes is the best, so I can get a few brownie points with Tom and the team. So create a project here. Um, and now I want to do a new scenario. Like, I'm going to pick a country, sort of ask a sort of energy modeling question. But I don't want to do any pipes. I don't want to do any Python because that's hard. So let's call it. I'm going to be less exciting here. Test pipes. Um, Go down. We have a select list of countries that you can choose at the moment. Um, Predominantly focused on around sort of Southeast Asia, because that's sort of the markets we've been focusing most recently, and sort of a underserved part of the country as part of the world when it comes to energy modeling as well. Sort of energy planning there generally is much less sophisticated than we see in North America and Europe. Um, so let's pick. I ran Pakistan earlier, so let's do Pakistan. And at this point, you can choose sort of high level metrics about the model you want to set up, like the number of nodes, and the modeling framework you use. So I'm going to pick three nodes, three grid regions. Going to stick with PyPSA, of course, but we also use the osmosis framework as well, which is another open source energy modeling framework. So yeah, this is just sort of the basic setup of the scenario. So I'm going to create this scenario. Get that bar out of the way. There we go. And then once this scenario is created, it'll let me look in more detail at specific inputs for this setup. So on the left here, we have lots of different things we can play with. So installed sort of residual capacity, typical pipes of things. And this you can edit these both for the osmosis and if you're in the PyPSA framework as well. So yeah, you can sort of go through these manually. You can download the template if you want to update some of these values, download a CSV and then re-upload that. But what I think is the more exciting way to do things, if we use AMP, our AI system. And what AMP is just an LLM, but it can do lots of things. It can tell you about your scenario, But also we can edit your scenarios as well. So you don't even have to click if you don't want to. So let's try that. Hey, AMP, I'd like to set the capital cost for solar to 0. Why not? China's just giving out solar panels. So let's see what it comes up with. Can take a few seconds. As we know, sort of like if you use Claude or anything, LLMs can take a little while to generate their responses. Um, might just give that a refresh if it's not doing anything in a second or two. Okay, but whilst it's thinking, luckily, I'm not going to run this model live because we know models take hours and I don't have hours. I've got maybe like 5 minutes left. So let's look at some results I've done earlier. So what have I got here? Okay, so I ran Pakistan earlier. So I'll just flick back to so this is that inputs, the input slide showing you the different variables that you can play with. But once you submit your run, you submit your model, that's when you can look at the results. So this is where we've got this results tab available now for this run that I did earlier. And it's got some high level information here, sort of such as your total operating capacities for each technology, different generation profiles. You can pick whatever time frame you want. And then if you want sort of the full results of this, you can download a CSV as well. Oh, I think I shouldn't have, I think I already had a different window open. Oh, there we go. So yeah, AMP is here now. It wants to do. It's asking me if I want to copy this scenario and create a new one or edit this one on directly. So edit this directly, please. Yeah, and we'll give that a minute. So this is our front end currently. But what I'd like to talk about now and sort of the work I focus on is the back end. Like what is actually happening when you click run? Is it magic? Like how do we get these results back? Anyways, once hasn't quite done this, let's edit the draft. Well, yeah, as you can see, AMP, you can ask it all sorts of questions like inputs, outputs, get it to do like a summary report, edit particular inputs. Again, anyone could log into this website. So yeah, any point you're curious, do log in, have a go, see what you can do. And yeah, there we go. It's edited the scenario. Lovely. Oh, it's editing. Yeah, it'll get there. So I'll flip back to my slides now. Because I want to talk about the back end, like what happens in between you clicking run up here and getting the results back. So what that looks like is, so we've just seen the front end, the website that exists on the user's computer. And what we have in our back end is we've got the sort of back end of scenario builder. It separates the user workflow from the model solving environment and only provisions the compute when a run is submitted because we know compute can be expensive. So that consists of two components. What we have running all the time is a lightweight microservice, and that is sitting there waiting around, looking for any run submit requests that come in. And that's running all the time. Lightweight, doesn't cost too much. And when it gets one of these requests, it says, okay, great, now I've got some information. I know that this person wants to run this scenario. Let me provision some compute because that request will come in. It will say how many gigabytes of RAM it might need. And then at that point, this lightweight service, it spins up a virtual machine with as much RAM as we need. And that's where most of the work happens, where the building, the solving of the model. So that's all happening in a sort of contained virtual machine that only exists for the amount of time that we require it for, so that we're not wasting money. To talk a little bit about what happens inside that virtual machine, this is where we use PyPSA. So yeah, three things happen in this virtual machine, but the user on the front end, they just see that simple run workflow. Whereas the platform handles model assembly, optimization, solver status, results processing behind the scenes. So again, three sort of key stages happen within that virtual machine. First one is building the model. So we're not passing whenever a basic request comes in to run a scenario, we're not passing all the model data around because time series data can be huge. So at that point, the virtual machine, it's going to our database, it's getting the full data for capacity factors, demand profiles, and then that very much in a similar way to as we do normally, like building a PyPSA network on a Jupyter notebook, say, it's doing something similar just within this virtual machine in an automated fashion. So builds your PyPSA network, saves that to a file, to a bucket, and then it moves to the solve stage. So same as you're doing locally. We use both Highs and Gurobi to solve the models. We save that back. And as we're going through this process, we're feeding like live status updates back to the user so they can see, is the model in which of these stages is the model currently? Is it building? Is it solving? Is it processing the results? So yeah, and that being the last step, the results, we take the PyPSA network, extract sort of key results as we saw on the front end, your capacities, transmissions, and sort of produce that sort of comprehensive CSV that people can download and look at in more detail as well. That about wraps it up. So yeah, thank you for your attention. If anyone has any ideas about how we may collaborate, I'm very happy to talk about that. So please do reach out. And yeah, please do try Scenario Builder. It's completely free. So the link is there. Go have a play. Launch an energy model. It will be the fastest PyPSA network you've ever built, I promise. Thank you.
Okay, thank you, Edward, for that wonderful presentation. Maybe we can have two questions. First is coming from Samuel. Since AMP is an LLM, how can you be sure your results will be deterministic? Have you thought about how this aligns with the reproducible scientific computing best practices? I think some people already are discussing, but can you answer that very quickly too?
Yeah, so yeah, AMP is indeed an LLM, so it's not perfect. Um, for the example that I gave, where for editing a scenario, that is something where I would go and check that has done exactly what you wanted. Maybe I can just get AMP back up and show us what it's done exactly. But as for sort of like um, oh, when you talk about deterministic, so AMP is only editing the input data. It's not getting involved with like the solving or anything like that. It's just helping you there to sort of interpret the scenario, change the inputs, interpret the outputs. It's not actually involved at all in the virtual machine sort of typical pipes are building, solving a network process.
Okay,
Oh yeah.
so I hope that answers the question. There are some questions and already some discussion in the chat, but let's have this interesting question. So, who is the target group of the scenario builder? Non-coders, but what kind of institutions?
Yeah, good question. It's difficult when you're building a product because you want everyone to use it. But the different users have different ideas from what they want from a product. So, the title of this talk I gave it, putting PyPSA in the hand of people who don't use Python. Um, but I would contradict myself there and say this isn't just for people who don't use Python. It's for anonymous cool. It's people who are technical as well who just want to speed up that process by which you can iteratively model. Um, so target users are ideally, typical energy modelers who could be in, government agencies, ministries, TSOs, but also the sort of people who typically don't interact with energy models directly. For example, key stakeholders who would never look at a Jupyter notebook, say, they would only look at a PowerPoint. It would be nicer for them if rather than just having a deck of slides of key results, they had something like this, where they could go log in and sort of interact with the results in that way. Um, and that will help foster sort of more engagement between stakeholders that is sort of somewhat difficult at the moment.